Go find the emptiest place you can imagine, not your room, not the sky above you. Go further. Picture the space between galaxies, the cold, dark stretches of the universe where there is no star, no planet, no dust, no atom for millions of miles in any direction. Picture a perfect vacuum, a sealed box with every single particle pumped out of it. Nothing left inside, not one atom of gas, not one photon of light. That is what you think of as empty space. Nothing, the absence of everything, a void. And it is one of the most wrong ideas you have ever held about the physical world. Empty space is not empty. There is no such thing as a true vacuum, a region of absolutely nothing anywhere in this universe, even in principle. What you call empty space is, in the most literal physical sense, seething. It is boiling. It is one of the most violently active places that exists, full of energy, full of activity, full of things appearing and disappearing faster than you can possibly imagine. And when you actually understand what is happening in the empty space around you right now, in this room, in your lungs, in the gaps between the atoms of your own body, you're going to realize that the word empty should probably be retired from the English language altogether. Let me show you what is actually there. Start with the simplest version of the problem. Take that perfect vacuum chamber. Pump every single particle out. No gas, no dust, no light. By every classical definition, this is empty space. Nothing should be happening inside that box. And yet, if you could look closely enough, with instruments precise enough, here is what you would find. Pairs of particles. An electron and its antiparticle, a positron, suddenly appearing out of nowhere, existing for an unimaginably short instant, and then annihilating each other, vanishing back into nothing. Then another pair appears somewhere else, and another, constantly, everywhere, inside that sealed box with nothing in it. Particles are popping into existence and popping back out. Over and over, an unending storm of creation and annihilation happening in what you were taught to call a vacuum. This is not science fiction. This is not speculation. This is one of the most well-tested predictions of quantum field theory, and it has a name: vacuum fluctuations, virtual particles. Here's why it happens, and why it has to happen according to the actual structure of physics as we understand it. The Heisenberg uncertainty principle says you cannot know both the position and momentum of a particle with perfect precision at the same time. The more precisely you know one, the less precisely you can know the other. This is not a limitation of our instruments. It is a fundamental feature of nature. But there is a second version of this principle that matters even more here, and it concerns energy and time. The uncertainty principle says that for a sufficiently short interval of time, the energy of a system can be uncertain by a corresponding amount. The shorter the time interval, the larger the energy uncertainty is allowed to be. What this means is staggering if you actually sit with it. For an incredibly brief moment, energy does not have to be perfectly conserved. The universe can, in a sense, borrow energy from nothing, as long as it pays it back fast enough that nobody can catch it in the act. And since Einstein showed us that energy and mass are the same thing, that borrowed energy can manifest as particles. A particle and its antiparticle can appear out of the vacuum, exist for a fleeting instant, and then annihilate each other, returning the borrowed energy before the universe's accounting books would ever notice the discrepancy. This is what a virtual particle is, not a permanent particle like the ones that make up your body, but a temporary fluctuation, a brief flicker in the underlying quantum field, borrowing existence for an instant too short to violate the books, and then disappearing. And this is happening everywhere, all the time, in every cubic centimeter of what you call empty space, including the space between your eyes and this screen right now. Trillions upon trillions of these fluctuations, every second in every direction, an inconceivably vast storm of temporary existence flickering in and out of being in what you were taught was nothing. Now, you might reasonably ask, if these particles disappear so quickly, if they cancel out before anyone can measure them directly, how do we know they are actually there? How is this not just a convenient mathematical fiction that physicists use to make the equations work? This is where things get genuinely undeniable. Because virtual particles in the vacuum produce measurable physical effects on real objects. Effects that have been confirmed in laboratories with extraordinary precision. Take two parallel metal plates, uncharged, placed extremely close together in a vacuum, just a few micrometers apart. According to the old classical picture of empty space, nothing should happen. There is no charge, no field, nothing pulling them together or pushing them apart. But that is not what happens. The plates are pulled toward each other. They actually move. This is called the Casimir effect, named after the physicist who predicted it, and it has been measured directly in laboratory experiments. The explanation is that the vacuum fluctuations, the virtual particles popping in and out of existence in the space between the plates, are restricted by the boundaries of the plates in a way that the fluctuations outside the plates are not. Only certain wavelengths of virtual particle activity can fit in the narrow gap between the plates. while a much wider range of wavelengths can exist in the open space outside. This creates a difference in the energy density inside the gap compared to outside, and that difference produces a measurable force pushing the plates together. Real metal plates in a real laboratory physically moved by the fluctuations of empty space. Think about what that means. Nothing, the supposed absence of everything, is pushing on solid matter with enough force to be measured with precision instruments. The vacuum is not passive. It is not a stage on which physics happens. It is an active participant, exerting real measurable force on the real world. There is more. The vacuum fluctuations also explain one of the strangest and most precisely confirmed phenomena in physics, something called the Lamb shift. Inside a hydrogen atom, the electron's energy levels are very slightly different from what the simplest version of quantum mechanics predicts, by an almost absurdly tiny amount. For decades, physicists struggled to explain this tiny discrepancy. The answer turned out to be the vacuum itself. The electron in the atom is constantly being jostled by the virtual particles flickering in and out of existence around it, and this jostling very slightly shifts its energy levels. When physicists included the effect of vacuum fluctuations in their calculations, the prediction matched the experimental measurement to better than 1 part in a million. The empty space around the electron is not a passive backdrop. It is actively interacting with the electron, constantly, and that interaction is precisely measurable. So when you ask what is in empty space, the honest answer is this: quantum fields. Every single point in what you call empty space is filled, not with particles in the ordinary sense, but with quantum fields, an electron field, a photon field, fields for every type of particle that exists in nature, all of them extending through all of space, all of the time. What we call a particle is not a little ball sitting in otherwise empty space. A particle is a localized excitation of one of these fields, a ripple, a disturbance, rising briefly above the field's baseline value, the way a wave rises briefly above the surface of an ocean. And the vacuum, what you call empty space, is simply the lowest possible energy state of all of these fields simultaneously. It is not the absence of the fields, it is the fields sitting at their quietest, calmest configuration. But even at their quietest, even at their absolute ground state, quantum fields are never perfectly still. They fluctuate. They flicker. The uncertainty principle forbids perfect stillness, the same way it forbids knowing a particle's exact position and momentum simultaneously. A field that was perfectly, permanently at zero with zero fluctuation would violate the basic mathematical structure of quantum mechanics itself, so the vacuum cannot be truly empty. It is mathematically required to be active, even in its most minimal possible state. This changes the entire picture of what is around you right now. There is no place in this universe, no matter how far you travel, no matter how thoroughly you pump particles out of a sealed container, where you can reach a true, perfect, mathematically empty nothing. The fields are always there. The fluctuations are always happening. Emptiness, in the absolute sense you learned to imagine as a child, does not exist anywhere in physical reality. What exists instead is a baseline hum of activity, present everywhere, in every direction, at every moment, an irreducible feature of the structure of the universe itself. And here is something that should genuinely unsettle you because it connects directly to where you came from. Cosmologists believe that the entire structure of the universe we observe today, every galaxy, every star, every cluster, traces its origin back to quantum fluctuations in the vacuum during the earliest fraction of a second after the Big Bang. Tiny random ripples in the quantum fields, the same kind of fluctuations happening in your room right now, were stretched and amplified by the rapid expansion of the early universe into the slightly uneven density variations that eventually collapsed under gravity to form galaxies. The same vacuum fluctuations that push two metal plates together in a laboratory are on a cosmic scale the seeds from which every galaxy in the observable universe grew. The nothing is not just active. The nothing built everything. So the next time someone tells you that space is empty, that a vacuum means the absence of anything physical, you will know the actual truth, which is far stranger and far more beautiful than the simple picture you were given as a child. Empty space is a roiling sea of quantum fields perpetually fluctuating, perpetually creating and annihilating particles faster than you can track them, exerting real measurable forces on real matter, shifting the energy levels of atoms, and ultimately responsible for the very existence of the galaxies, stars, and planets, including the one you are standing on right now. There is no nothing, there never has been. There is only the quietest possible version of everything, and even that quiet is never quite still. If you want to keep seeing the world for what it actually is, not what it appears to be, subscribe. That is what this channel is for.